All right, I'm getting the indication that people are being let in. This is good. Okay, it is 10 o'clock on March 28th. It's opening day. Yay. Welcome to a non-opening day subject, but it's fine. Um, Delivering high performance using very high efficiency DOAS systems. We've got Shawn from Ecotope and Chris from NEEA giving us some expert, uh, not advice, information, expertise on DOAS, which is uh, fairly new, at least in my world. So very interested to hear what they have to say about these. Just to do a little housekeeping, if you've not taken a webinar with the Lighting Design Lab before, you are all on mute the whole time, but there's this little question mark that you can type your question in, and we'll get those answered. Ask at any time during the presentation, and we will have a few pauses and get those answered. The chat icon is different. You can't use the chat, but we can paste things into there for you, such as pertinent websites or any information. Um, this webinar is being recorded, so if you need to step away or if you want to share it with colleagues later, we will have this posted on our website. Give me about a week. Sometimes it's the next day, but give me about a week. And then there's a survey after class that we would really appreciate you taking. What is the Lighting Design Lab? And why are we doing a DOAS presentation if we're the Lighting Design Lab? We have been called the Lighting Design Lab since 1989, 1990. And BPA and other Northwest utilities got together and saw a need to transform the lighting market and educate the lighting industry on the benefits of the cutting edge fluorescent technology. But then came LEDs, and now everything is connected. So we need to expand our offerings to include whole buildings and support city and state decarbonization goals. And just for the future, we've got City Light staff coming the beginning of April to talk about a new, sort of pretty new, controls upgrade incentive. So come hear about what money you can save with a major controls upgrade. And then we have some Mitsubishi folks coming to talk to us about HVAC's role in the electrification roadmaps. It's really, I would say, geared more towards HVAC installers and yeah, installers. But it'll be interesting to hear what their opinion is from a manufacturer perspective. And then we had Evan Green here to talk about commercial heat pump water heaters a couple weeks back, and it was a very engaged audience, and we didn't get to everybody's questions. So we are having him back to answer those questions, and if you sign up for it, you have the opportunity to submit your own questions ahead of time, and that's at the end of April. Don't forget the Vision Awards are coming up, 2030 District. I think they have a discounted ticket that ends today or tomorrow. And then visit the City Light booth at AEE West at the beginning of May. And just to make sure everybody's paying attention, we've got some Slido polls here at the beginning before we get the presentation going. You can get out your phone and scan that little code, or go to slido.com and type in those numbers and get into our very important poll. Happy Major League Baseball opening day. Who do you root for? This is the most important question of the day, I think. I'm going to give that a second for people to get into Slido. There we go. We've got some participants. And I would say, good, okay, Mariners. I will accept baseball is boring. The Aqua Sox, yes. All right, good. Okay. Let me go to the next. Oh, the Red Sox. Fine. Fine. The Giants, good. Oh, I love the Pickles. I love the, I don't watch sports, valid. I like the Savannah Bananas. They're a new-ish, goofy baseball team. Okay, but now let's do Mariners, I guess. Yeah, you're a good Mariners fan. So now's a couple real ones. Where do you do most of your work? So not where do you work necessarily, but where is your work done? Great. Cool. Pretty local. Shawn and Chris are calling in from Portland, and I am right downtown in the middle of the clouds. Thank you. I'm gonna go to the next one, and just kind of wanted to know what everybody knows about DOAS. During a webinar in fall, this technology was mentioned, and I did not know what they were at all. Um, cool. Okay. So a lot of people know what they are, but not a lot of people have used them. Great. Thank you for your engagement, guys. I'm going to hand it over to Chris and Shawn. I need to make... Shawn, you're going to be the presenter, right? You're going to run the slides?
Yep.
Yeah. And here we go. Thank you, everyone. Enjoy the presentation.
All right. So I'm going to start off in going through a few slides, kind of talking about, generally what DOAS is, and then I'll turn it over to Shawn to go really deep into some really cool case studies that he's got that sort of really highlight how great the DOAS, VHG DOAS is. Um, so again, I'm Chris Wolgamott. I'm with NEEA. Shawn, you want to introduce yourself just real quick?
Shawn Oram with Ecotope. I'm principal of design and engineering.
Yeah. So next slide. Um, so one of the things that we have is that we're just going to kind of really talk about some high performance HVAC systems, what VHG DOAS is. We're going to talk how it kind of applies to Washington Energy Code. We'll talk about the pilots, and then hopefully we'll have time at the end for some questions. So next slide. Just really quick, I'm going to hit on, for those that don't know who NEEA is. NEEA is a alliance of 140 plus utilities in the Northwest, in Oregon, Washington, Idaho, and Montana. We've been around since 1996, and we basically define ourselves as a market transformation company, and we work with the utilities to bring new and advanced technologies that increase energy efficiency to the market as fast as possible. So for me personally, I work on the product side. So I look at things that maybe are 5, 10, maybe even 15 years down the road, and with the goal of bringing them forward, bringing them into the market faster so that we can get as much energy efficiency as we can. And this VHG DOAS is one of those products that NEEA is very excited about. We think there's a lot of potential with it. Next slide. So Better Bricks is sort of our forward-facing entity. It's where we put a lot of our studies, a lot of our information. We've got a lot of tools there, a lot of things for people to be able to look at. It's a really good website for everybody to sort of see and understand what projects we have, and it includes everything, right? So it includes the HVAC stuff, it includes windows and lighting and water heating, and even some appliance stuff. So it's a really good educational place for everybody to go. So next slide. Um, Inside that Better Brick Solutions, we always try to look at sort of this holistic look at how a building is applied. So we start with envelope in the one, which includes windows and secondary triple pane, that kind of stuff, and then internal gains and equipment. So that could be lighting, luminaire level lighting controls, smart plugs, and then the third sort of bank is the central building system. So that's smart pumps, circulators, heat pump water heaters, VHE DOAS, and efficient rooftop units. And they all lead to energy efficiency, which leads to energy to saving money. So that's kind of the scope of what Better Bricks looks at and how that looks. So next slide. And we're just going to really talk about why high performance HVAC. So if you look at buildings today, a lot of these buildings, in most commercial buildings, what we're seeing is right now, more than 50% of the energy used in a building is used by heating, ventilating, and cooling. So when we look at that, that's a big chunk of the energy used by the building, but it allows us to know that this is a good place to focus, right? So there's a lot of other places in there with that, but this is a really big chunk of what a building uses. And so it's a great place for us to look at to save energy. The next slide is kind of shows building types. So we can, a lot of these systems, we can look at all of these building types, but the three main ones that we look at right now are education, retail, and office. And if you look at those, over 50%, and in some cases 60% of the energy used by that building is from space heating, cooling, and ventilation. So, it's really a high use of those building types. And in some cases, some of the small other buildings in there, they even use more than that. There's just not as many of those buildings around, right? So with education, retail, and office, it allows for a very large chunk of the building supply stock that's out there, right? So next slide. One of the other things with high performance HVAC systems is that it's more than just energy savings, right? We can definitely see it, and we'll show that. But one of the big things I think nowadays is that it improves indoor air quality. Indoor air quality has become a very big thing. With COVID and everything, there was a lot of talk of that. But it also increases occupant comfort. Regulates the temperature better, keeps it more stable throughout the time. And again, saves that energy and money, right, when it comes to the bills and your energy use. And the other nice thing right now is it meets or exceeds all of the 2021 Washington State Energy Code for most of the DOAS and building types. So the next slide is just sort of just a note to say how much ventilation and indoor air quality is starting to become a bigger part of the picture than maybe it was before. It's always been there, right? It's always been a piece of it, but we're starting to see even more focus on that. And I think that when we start to talk about what VHE DOAS and high performance systems are, this is a piece that is really important part of it. Not only does it save the energy, but it increases that indoor air quality, right? So next slide. So we're going to talk a little bit about what VHE DOAS is. So very high efficiency DOAS. And for everybody to know, DOAS itself means right, dedicated outside air system. So what we've got is with NEEA's VHE DOAS, we've got a system that we're seeing on average HVAC savings of 69% and whole building savings of 48%. So those are big numbers, right? For changing that's just changing your HVAC system. That's not touching anything else really, your HVAC and ventilation system, right? So that's changing that, and And what we're doing when we do this is we're pairing a high efficient HVAC equipment with design principles that provide excellent indoor air quality and enhanced thermal comfort while reducing HVAC energy use in the building, right? So next slide, I'm going to kind of go through what this is. So the first thing that we need when we have this system is that we're going to fully decouple, so that when if Shawn, you'll hit there we go. So we're going to fully decouple this. So what we're going to do is we're going to separate the ventilation air from the heating and cooling fan coil units, right? So, and this approach allows these two systems to be controlled and optimized to provide critical functions that they're intended to do, and you're not doing crossing, right? So you're not having the HVAC, the heating and cooling system providing the ventilation, which can cause, you know, increased energy use for that, right? So and so now you can schedule the ventilation system to be controlled to meet the ventilation needs according to occupancy, so it's flexible. And at the same time, you'll be allowed to, the decoupled primary heating and cooling system can deliver cooling comfort of conditions and controlling the temperature based on the zones, right? So the next piece of our system is the high efficiency HRV or ERV, so the heat recovery or energy recovery ventilators. And with what we do require greater than 82% sensible effectiveness on that. But what we're doing here is we're providing the ventilation to the occupied space independently from the cooling again, right? But what's happening is with those high efficient ERV, HRVs is you're preconditioning the incoming air. So you're getting 100% outside air coming in for your ventilation, but you're preconditioning it with tempering it with the return air from the space. So so a lot of times you're eliminating the need for supplemental heating and cooling because the air that's coming in is being preheated or pre-cooled, depending on what your need is, within a few degrees of the conditioned space, right? So you're providing that air. And so we've seen in systems in coastal and valleys, so control, climate zones 4, that the supplemental heat has been minimal for these, in those ones, and in for the climate zones 5 and 6, which are a little more extreme, right? But this separating and using this HRV, ERV is critical in decreasing the runtime and energy consumption of the heating and cooling system. So the next one is we're also pairing up the high efficient ERV, HRV with a very high performance heat pump system, right? So this is typically what we see. They have variable speed inverter driven compressors, variable speed fans, and a zonal approach. VRF mini splits are the most common, but we have seen hydronic systems served by high efficient air to water heat pumps or central plants as well, in these systems. And the last piece is right sizing. And I think this is something that maybe gets underplayed a little bit, but the right sizing, the cooling can not only save money on the first cost, right? So what it costs, because you can put a smaller HVAC unit in, so you can save a little money there because you're not running it, but it also saves the energy by not short cycling or running during load conditions, right? And so what we've seen is that we can really right size this without having to oversize the HVAC system to provide it. And one of the things we're seeing right now is the sizing can be anywhere between 500 to 750 square feet per ton. So that's good, right? So next slide. So I think here what we're seeing is the other thing that we've done is does it work, right? Does the system work? And we've had 14 pilots spread throughout the Northwest in all, like I said, about three or four different climate zones, from Seattle to Portland to Montana to Eastern Oregon, and all different sizes and all different building types that show that this energy savings is there. So we have the next slide, which kind of gives you a breakdown of what the energy use. So the EUI for these buildings were. And if you look at these, each one of these is all the buildings that were done. And you can see that there's a fairly significant drop in the kBTUs per square foot in a year in all of them. If we hit the next button, it'll highlight over here on number 15, which is the average, right? So the average shows that pre-conversion, we went from 65.3 to 34.2, so almost cut it in half. And that's the building EUI savings. And just the HVAC alone, again, that 69%. So we're seeing really good savings. I mean, probably better savings than we, you would see in most anything else that you're doing by doing this. And I will say that one of the things that we have on this is that because of the way you have to design the systems, that every building and HVAC system is unique, right? So we have to there are challenges on each one, but we're seeing that the savings outweigh most of those challenges, right? And it's really showing up good in the Northwest. So next slide. This next one, we're sort of looking at only the ones in climate zone 4. And, one of the things that we see here is that the amount of energy savings or the usage in here is that we're having significantly low EUI for the HVAC system. The average is 11.4 kBTUs per square foot per year, right? That's really good, right? That's below what the average of where almost all code looks like wants you to be, right? So in this one, we did pull out. We looked at 9 climate zones, office and schools in this climate zone 4. This is climate zone 4. And we're within 2 EOI points of the average for 7 of them, right? There's a few that are a little off, but for the most part, we're right there. And it's important, I'm focusing on this climate zone 4 project, but the colder climate projects in Montana and Eastern Oregon were also very successful projects, and they averaged 50% HVAC savings. And the potential for savings is even higher on the absolute level because of the magnitude of heat loads, right? So heating is, if you look at this, heating is the largest chunk of this. Cooling and ventilation are there, but it's not the biggest. It's the heating. So get into those colder climates, the heating side can provide even greater savings. So next slide is, so if we want to hit the first button there, what contributes to the energy, to the high energy savings? Again, it's the heating and cooling, right? You can see that the average from one side to the next. If you look at this graph, one side's pre-conversion, the next side's post-conversion. We see heating's reduced by 65%, and cooling is reduced by 48%. And then the fans, the DOAS effect. So using high efficiency fans with outside air, you move less air, you optimize the controls, and you've got, again, those efficient fans. You get 84% reduction in your fan usage. That's a big deal, right? That's a lot of energy use right there. But this is where the energy is coming from, where the savings are coming from, and how we look at it, and where we're seeing all the savings. Okay, so now we're just gonna kind of quickly go through how this relates to Washington, how this VHG DOAS versus the Washington Energy Code. So this is what the definition is of the dedicated outside air in the 2021 Washington State Energy Code. And if you hit the button 2 more times, Shawn. This is the buildings that it applies to, right? So assembly, business, education, retail, basically. There are a few exceptions, but for the most part, it covers all those, all those. And next slide. One of the things that we see here is when you have that, dedicated outside air system and the applicable building types, is that VHG DOAS is really good for commercial buildings that are about 5,000 square feet and smaller. That fits with, with what the code says, right? It requires DOAS in many commercial buildings, and the very high efficiency DOAS is an excellent solution for the small to medium commercial building applications, and that's what we're seeing in the studies that we've done. Next slide. And in this one, it's about the ERV HRV, right? So again, I think I've noted it, but in NEEA's program, we require 82% sensible effectiveness on the ERV HRV. In Washington code, their base is 68%, so obviously the 82% meets that. But the other thing is that in their high performance option path, they require 80%, so we meet that as well with what we have as a system. So not only does it meet the base, but it also is better or meets in the performance path as well. So next slide. And then the next one is the fan power for DOAS. Again, same kind of thing. Our program sets it at 1.3 CFMs per watt. That's 75% of nominal airflow. And if you look at the performance path and the standard path for the code, this meets and exceeds it. And they actually matched our path, for the high performance path, they matched what our CFM is for the fans. So next slide. So we're gonna just jump into a couple. I'm gonna talk about some really high level, like 3 really high level case studies, and then I'm gonna turn over to Shawn to talk in depth on some really interesting case studies that they've done. So on this building, this is about a 6,000 square foot building. I think when we look at these next 3 slides, the key things to take a look at are the EY differences, and then also to look at the sizing on each of these systems. So the existing building had a VAV system with a combined heating capacity, including reheat coils in the VAV unit. So it had 16.4 tons of heating and 14 tons of cooling. It went to 1 VRF heat pump, 1,000 CFM HRV, reduced the heating load a little bit, kept the cooling load the same, but we went from an EOI of 51 to an EOI of just under 30, right? So, and then the other thing about this one that was really nice is it had peak energy savings that were reduced in the winter and the summer by a good number, right? That this one, the next one is this office is, went from 2 constant volume packaged gas RTUs and a split system heat pump that were 28 tons of heating, 20 tons of cooling, to 1 VRF heat pump system with 2,000 CFM HRVs. But it went from that 28 tons of heating to 11 tons of heating and 10 tons of cooling. So more than half of reduction in the heating capacity and half of the cooling capacity. And it went from an EY of 62 to 13. And that's that right sizing that we talked about earlier with the system. If you can reduce the size of your mechanical heating system because you've got the HRV system on there to help provide some of that, that's a lot of extra energy savings that you can provide, right? So this is a big deal when it came to the energy reduction of that. Next slide. So this one's a little bigger building, again in the Portland area. It went from 9 RTUs, 43 tons of heating, 35 tons of cooling, to 1 VRF system, 4,000 CFM HRVs, and it again dropped the heating load from 43 to 18 tons and from 35 to 16. So again, you cut it in half, right? More than half. And you reduced the EOI from 51 to 19. Pretty constant when we look at this, that we've seen a ton of these showing the huge energy savings, the UI drops. But again, like I said, I think the right sizing gets lost a little bit in the mix here. It's really amazing to me that you can take this and drop what was there for that space and have them, really size down these units and still meet the needs of that space, right? Next one. So this one is kind of an interesting one. It's a really small space, less than 3,000 square feet. 3,000 square feet. It was a constant volume 5-ton package heat pump ton RTU. That we went to 2 1.5-ton ductless heat pumps and 1 2-ton ductless mini split and 1 1,000-watt CFM HRV. Right. Again, we cut the EUI in half. But this one is kind of interesting because I think it's the first and only net zero preschool in Oregon, and maybe the Northwest. We obviously don't keep track of it. But they started with a passive house design principle, so the envelope was good, and a very small HVAC load, right? So, and they put 40 kW of solar PV on it as well. We've had a lot of interviews with them, and the school administrator and staff have been blown away by the improvement in the thermal comfort and the indoor air quality for this project. So this was kind of a fun one just because, it met all of that and became a net zero building. Okay, next slide. One of the questions that we do get on this is, can these systems meet the needs on the extreme, right? Whether it's a cold extreme or a hot extreme. And so what we're seeing here is in this graph is the office space that was in Portland a few years ago. I guess it's 3 years now. Time flies. We had a heat dome, right? And so we had a few days in a row where the temperature was at or above 110 degrees outside temperature. And the building we were able to track and monitor, and the set point inside the building was 75 degrees. And on those 2 heat dome days, we were able to keep the inside temperature at 35-degree delta T with the system, even though it was so hot outside. And the energy use wasn't massive compared to buildings that were doing the same thing and not able to keep up with the cooling needs in those heat domes. And this also works on the cooling side as well, right? So we've had a few days where they're in the mid-20s, and this building's been able to keep their temperature at the 70-degree mark and quite comfortable. So we've had a really good response with this system on the extreme days as well as the days that are normal days. So that right sizing, again, is still effective. So I think now I'm going to let Shawn talk about a little more in depth on some of these projects.
Great, thanks, Chris. So just a little high level, Ecotope works a lot both on kind of emerging technology research as well as design. And so I'm going to talk about some of the design work that we've done. And then I'm going to, so in sort of 3 case studies that have VHE DOAS installed, I'll kind of walk you through a little bit of the process. And then also put sort of a clean buildings lens over these buildings, just to kind of show, what when we do these VHE DOAS systems and other measures, what type of savings we can get to sort of frame it up. Clean buildings, if you're aware or not, is a Washington state policy, and it is going after essentially getting buildings within sort of an upper threshold EUI. So there are EUI targets, and a lot of the existing buildings, there's a more detailed kind of summary to the right. But all of these buildings out there that meet this size class, what we call the tier 1 buildings, those will have to show compliance in the next 3 to 4 years, or come up with sort of the alternate path on those. But without further ado, so the first case study I want to talk about is a project up in Sitka, Alaska. This is a Sitka Public Library. This project was started in 2014, completed in 17, and the reveal here is the EUI is 32. So I'm going to walk you through a little bit of kind of how, kind of the background on the story. But the high level is this library in this upgrade. It was sort of at end of life oil boilers. It also added 50% area to the program, and so that's a piece that's sort of not real clear in here. So just want to kind of make that up front. But we started this project and we looked at sort of a benchmark looking at Seattle libraries and wanted to see, where is the Sitka library? Sitka, Alaska is quite a bit colder. It's about 7,000 heating degree days compared to Seattle's about 43. So it's quite a bit colder up there, as more extremes. Pretty much heats year round, all through the summer as well. Mornings get cool enough that you have to engage some heat. So this, presented, in kind of a good case for VHE DOAS. But just looking across the board, the average EUI of Seattle libraries, and this is sort of benchmark data, is about 81. The Sitka Public Library, when we looked at the project initially, was 101. So and we had targets for much lower than that. And so just getting into the systems, this is a classic Alaska building system, which is kind of a central air handler with ventilation air ducted into that return air plenum. And then those fans just run 24/7, or during occupied hours for the library. There's a separate sort of oil boiler. You can see it off to the side. And this project, most of the equipment was near end of life, and there was kind of big changes happening at the kind of the program and architectural level. So this was mostly just a down to studs remodel, which presented quite an interesting opportunity for us. So the first thing that we did is we kind of looked at the whole system, the new program, and thought about, really a big move on conservation. So super insulating the envelope, as well as putting in some high efficiency HVAC systems. And we were able, just with the conservation play on this existing building, we were able to kind of sell everything, including the envelope, just on the mechanical heat load savings. So the savings that we got by implementing all these measures, the resulting HVAC size was significantly smaller, which then allows you to kind of push forward with the whole program being much more efficient. But we kind of summarize, triple glazing and basically, high efficiency envelope. Walls have 4 inches of foam in the outside. We put a topping slab in under R20 insulation. And this project essentially put in what amounts to an air source heat pump, as well as a VHE DOAS system. So this is kind of the tieback. But the VRF system, you can see it over to the right, was set up as a to feed hydronic radiant floors. So it's a low temperature system. And then there's a high efficiency VHE DOAS system. This is kind of a built up system. You can see it down on the left of the picture. And that's about 85% efficiency and about 1.4 watts or CFM per watt. So it's really efficient system. It's also quite appropriate for this location. It's hard to get parts up in Sitka, and so the contractors really like the idea of having, kind of a built-up system, and so that's exactly what this is. There's a core. You can see that white device lower left, and essentially fans and filters on the outside feeding through that core. So that core should have a life, 40, 50 years, and the fans individually can all be swapped out if they go bad. But this is a really good solution for kind of remote. Everything has to be sort of redundant systems up in Alaska. Another kind of opportunity that presented us here was the computer lab. They have like 30 computers. This is like a central area in the program. And we essentially connected up the computer lab cooling with the radiant floor through the VRF system, so that we're taking all the waste heat to put it into the radiant floor. So that also contributed to some savings. But I mentioned the kind of the load reduction, the VHE DOAS, and so that we had a pretty significant reduction in peak heating load, and that was the mechanism to pay for the rest of the conservation package, which was the envelope and the VHE upgrade over regular DOAS. But we can see a pretty significant reduction in the heat plant. The original boiler was 500,000 BTUs, and the new one was somewhere around 168. So pretty significant and lots of savings in terms of kind of first cost. Here's a little bit of measures are listed over to the left. The before and after. One of the goals here was to get rid of heating oil. Pretty dominant in Alaska is to use heating oil for heat. And so we were able to both eliminate the heating oil and reduce the overall energy use. And you can kind of see before and after over to the right in that graph. Keep in mind, this also accounts for a 50% floor area increase. So the savings are actually bigger than what is evident here. This is an interesting tool that we use a lot when we get into existing buildings. We call it change point analysis. But you're essentially looking at the EUI signatures for both the heating dependent signature as well as the base load. So an example would be the before case would be the blue and the green line. And you can see the green line across the kind of the middle there. That's 40 EUI, and that represents all your base load. That's your fans, your lights, your plugs. And then the blue line represents the kind of the temperature dependent EUI loads, and that's very typical for buildings. And you'll see the slope of that line, and then you sort of look at, and that tells you, that's sort of an indicator of how efficient your building is. And so the lower that slope is, then you can kind of tell if you've got an efficient building. There's other things you can tell, but this is kind of a pretty key piece when you start looking at building to building and kind of comparing high performance versus not so high performance buildings. But you can see the base load went from 40 to 20. Most of that was LEDs and kind of upgrades to plug loads, computers, better computers. And then the space heat load, the temperature dependent EUI curve is much, it's about half the slope there. And that's a pretty key indicator of a high performance building, is when you see a slope kind of that shallow. And then kind of putting this up against both the clean buildings and the original benchmark we showed. Clean buildings line for libraries for Washington State is 56. We can see that none of the libraries in Seattle are meeting the clean buildings criteria currently. And we can see what happens with a post retrofit with a VHE DOAS and big investment in the envelope. We can see we ended up at 32. So this is kind of what's possible out there using both the VHE DOAS and kind of conservation and really paying attention to kind of the energy use. So the next one I want to talk about is a little more local. This is a King County International Airport. This was completed in 17. There's the reveal, the EUI 51. So a little background, very similar story. It has a multi-zone system, which is a system that we don't use anymore. But it's basically a giant air handler that makes hot and cold air. And you have a bunch of valves that are dampers that open and close to serve each room. And so they kind of mix everything at the air handler. And so the EUI of this current space was about 168, the library, before we looked at it. And through mostly just a VHE DOAS and heat pump installation, we managed to get it down to 51. It's using just a tiny sliver of gas for some process load, but there is no gas for HVAC, and it's all VHE DOAS and heat pumps. This is, again, just showing that energy use, but more across when it was used. And so you can see a big heating signature in the summer and a big heating signature in the winter and a big cooling load in the summer. And that's pretty typical. But like I mentioned at the bottom, it doesn't zero out. So there's always heat and cool going on these type of systems. Not very efficient. Again, there I mentioned the multi-zone before. You can see the size of the system. And sort of after, there's a VHE DOAS sitting on top of the existing curb where the multi-zone was, and then a small little VRF plant next to that. So that kind of shows some of the significant savings when you also downsize. So there's significant downsizing in the capacity as well, kind of right sizing. And then putting this up against the clean buildings law, airports aren't specific in there. I chose public assembly. That might be debatable, but it's a number somewhere like this, 66. And so this shows that airport is below the targets or does meet the clean buildings targets. So this is another example of kind of a heat pump retrofit and a VHE DOAS, kind of delivering on performance and comfort, which was another piece. Okay, third project I want to talk about. This one is located in downtown Portland. There's an old historic building called the Galleria. It's a gorgeous building. And this particular kind of case study covers the top floor in this building. So this project, we did a full electrification kind of core and shell delivery. And then the top floor was built out by the tenant, who is Sarah Architects, local to Portland and Oakland. But this was completed just last year. We don't have an EUI yet. It's modeled at 25, so we'll kind of see where it goes. There's a lot of pretty cool things we did here. But the thing I did want to talk about is something that we've had a lot more inquiry about, which is what to do when the wildfire smoke hits our region. And that's been happening pretty regularly in the last 10 years or so. And so in this project, there was a very specific IAQ agenda inside of the design. And so I wanted to kind of show what we did here. And we've got a VHE DOAS system, but instead of just kind of stacking up the VHE DOAS with a bunch of filters, inside or before, we actually install the pressurization, sort of a bypass loop, and HEPA and carbon filtration. And so the idea here is we look at the outside air when the PM 2.5, particulate matter 2.5 micron in size, gets up beyond a certain threshold, we engage the wildfire smoke system. And what this does is it pressurizes the building so that infiltration isn't allowed in, but it also kind of forces dedicated outside air through really fine filtration and carbon to get rid of smells from the wildfire smoke. And then delivers it to the space. And this happens sort of automatically with the control system designed. This sort of shows in plan how it's set up. There's two horizontal high efficiency VHE DOAS systems in here. And then we've got a little bypass loop that sort of drops down and back up. This is it in installation. So there's over to the left, you can kind of see a little bypass loop. There's some dampers, but we run down through some filters through a fan, and then push through the VHE DOAS system. Over to the right, you can see the HEPA filter bank. It's about 14 inches deep, and then some carbon up top. This is another variation of it on the same project, but it shows, this booster fan sort of pushing through some really high, really fine HEPA filtration just to kind of get rid of any smoke. And then kind of some of the results before and after. So this building was actually built this project was designed around a design for off approach. There's been some earlier sessions around that, but essentially if the outdoor air is adequate for conditioning, we turn everything off and we open windows. And that's kind of a passive mode. Then we've got high efficiency mode whenever we need heat or cooling. And then we've got a third mode called IAQ mode, or bad outdoor air mode, as it's labeled here. But it essentially looks at the outside air, so outside air, and says, if the levels of PM 2.5 are, higher than about, if I think it's 14 is our threshold, engage this system. And we can see in the graph, when it engages, we watch the indoor PM 2.5 kind of drop. And so it just sort of cycles like that as needed. And then here's kind of backing out. This is last year when it first came on board. We haven't been through a wildfire session with data. We're still kind of working on getting the data stream. But this was kind of a normal urban environment. So before the wildfire season, and you can see the outdoor PM 2.5 levels, quite a bit higher than that 12 threshold the EPA kind of sets for PM 2.5, and then we can see what we get on the inside, after we're kind of using this system. So pretty impressive. And during the wildfires last year, just anecdotally, the feedback was very positive on the effects of this. And then again, kind of the clean buildings lens, 25, much lower than the 63. So just another kind of unique application, I think, for VHE DOAS, and just a way to kind of, enhance the offering on the VHE DOAS, and really start to kind of hone in on indoor air quality and being able to kind of deliver in the face of, climate disruption. A little preview on some of the services we offer. Happy to talk to anyone if you'd like to afterwards. And I'm going to swing this back to Chris.
Great, thanks, Shawn.
Yep.
So I think the next few slides, we're just going to talk real quick on like some of the key elements of the VHE device. And so we talked about this slide earlier, right? So ventilation, high performance ERV, HRV, high performance heating and cooling, and right sizing. So these are the things that make VHE DOAS different and provide such great energy savings that we've seen. So next slide. So on, one of the things that we see with indoor air quality is, we're really looking at how an HVAC system, doesn't have to be, cost so much to operate when it's resilient, right? So we did a study, found that the high efficient DOAS was able to significantly increase ventilation rates, which can reduce the risk of many things, whether it's smoke from fires or viral risk of viruses inside the building, and still using 37% less energy than a similar system, a VAV system. And you can see that with this graph over here on the side, where we show the energy costs from acute ventilation versus code minimum ventilation, right? So the green being the VHE DOAS almost always comes in at half of what the code one is, and then the blue line is the single zone RTUs with gas, right? So we're seeing really good savings, but we see an increase of in-air air quality as well, right? So next slide. One of the things that we also get to, like to point out and talk to is that there's a lot of product out there right now that meets this 82% ERV HRV. And that's a key to this, right? It's tough to really push on a product if there's only one or two out there, but we've got all of these groups, right? So Green Hex, Wagon, Oxygenate, TempF, Ventacity, and the Flex group that have product that meet this. And so if we go to the next slide, you can see that we have right now, there's 6 manufacturers and 80 models. But I think in our next, we re-update this about every quarter. I think the next one that comes out is going to have 7 manufacturers now and more than 80 product as well. And we're adding product constantly to this. So it's really, there's a lot of product to choose from, a lot of different versions of it. And I think I saw a question earlier that said, do they all have to be outside mounted ERV, HRV? And my understanding, and Shawn, you can tell me if I'm wrong, they don't have to be, right? You can have internal mounted ones. They don't have to be outside. That just happens to be the ones we took pictures of because it's easier to take pictures of something sitting on top of a roof than inside the ductwork inside the building. So, but yeah, so lots of different options here for sizing and for product that's out there. And then I think next slide is just sort of if you've got, I mean, we'll definitely be here to answer questions, but if there's, other questions that you have, there's a lot of places, especially at the Better Bricks, to be able to find some of the answers. And you're more than welcome to email me with questions about VHE DOAS. But we have case studies, the pilot reports and findings, design requirements and guidelines, our QPL for the ERV, HRV manufacturers and products, and any research we've done, including economic and indoor air quality analysis, can be found at the Better Bricks site as well. So, I think that's probably the end of our presentation. So we're open to questions, I think.
Great, you guys just booked through that. You just addressed the first question that we had, but Lisa had I sat down and my camera's weird now. Lisa had a good question. She said she didn't see DOAS as an option for multifamily retrofit projects or retro product projects, excuse me. And she wondered why not. She thought that it might be a good option for bringing fresh air in when you're tightening the building up.
I'll take a spin at that. The current code right now for multifamily new construction does require VHE DOAS, not VHE, but does require DOAS ERVs. And so ERVs for multifamily are required for new builds. With existing buildings in multifamily, they can be a pretty good retrofit measure, but you're not going to see as much savings in residential simply because the airflows are so small. They're a lot smaller than you'd get in more commercial kind of airflow quantities. But that said, if you're looking to bring EUI or just overall performance or just savings down, ERVs can be an effective measure, but they're a lot trickier with existing buildings, fire ratings, et cetera, but not impossible. There's a lot of, several low-income housing agencies that are retrofitting kind of old, 80s build housing units with DOAS and VHE DOAS. There's also a few we didn't talk about, which are kind of the push-pull ceramic core style, Lunos and Vents US, and those are certainly options for kind of smaller apartments that I think are pretty good for retrofit. But there are certainly, applications for multifamily all around, and there's, we've been designing with them for many years now for residential.
Great. And then another one, Alyssa, sorry, has seen installed downstream of DOAS to supply neutral temperature into the space. With VHE DOAS, can you eliminate, the the tempered coil and still supply neutral temperature for climate zone 4?
Absolutely. I'll take a stab at this. I think that's actually one of the biggest kind of value propositions for the VHE is you can eliminate any trimming that you do on that outside air. And so if you look at the cost to add the coil and add that capacity to your plant, compared to just looking at the upgrade cost for the VHE, I've done this on commercial projects, looked at that kind of delta, and it's actually the VHE is a better life cycle kind of cost number. When you look at that, just the savings are always there. There's not nothing to go wrong in that trim coils. Something goes haywire. Sometimes you have to. You've got maintenance items associated with the coil and cleaning it. And so once you factor in all of those items, I think, it sort of makes the case for going to the VHE DOAS. Chris, I don't know if you wanted to add anything to that.
No, I think that's I would have gone that same route. I think that you can absolutely do it, and I think that there's a lot of benefit from it, like you said.
Yeah.
Great. Okay. And then Marcus is wondering why most DOAs in the Pacific Northwest seem to use ERVs instead of HRVs. And he says, given that our RH levels would easily allow the use of the latter.
Yeah, I mean, I won't speak for all of it, but most of the case studies we have do use HRVs, not ERVs. In some cases, I mean, from my understanding, that it's not overly, it doesn't matter too much. It could be a cost thing, it could be design thing, but you know, all the case studies that I did, they did use HRVs instead of ERVs. But Shawn, maybe you have a
Yeah,
different.
I've done both. And generally speaking, my experience has been that it's not super critical for most of the building types, but if you get into a scenario where you've got any sort of moisture control, you actually want to use, where you want a little bit more security in sort of excess humidity. Using the HRV is safer, but the ERVs, sorry, let me back up. So the ERVs, what they do is they tend to keep the water on the moist side of the unit. And so you've got your HRV, and you've got your outside air connections, and you've got your inside. But if it's super, saturated outside, rainy, cold weather, that moisture will transfer across the coil and exit the building versus dumping into the building. And so that sort of makes the argument for the ERV. But when you get a space that's super tight, like a passive house, or that's really tight, and you don't have a lot of air movement, air exchange, through there, then the HRV is going to be safer, because that super tight space will tend to build up. And so you do have to sort of account for that. And when you get the tight spaces, I'd recommend you upsize your HRV a little bit more, so you can kind of over ventilate if the moisture becomes an issue. Hopefully that sort of answers the question.
Well, if it doesn't, Marcus, you can let us know. That's the end of the questions that have been submitted so far. Um, just give people a couple more minutes to. No, here comes one from Nicholas. Um, and actually, this is what I was going to ask. What type of maintenance is needed for DOAS units? And I was thinking specifically because of the wildfire smoke. I didn't even think of that until you brought that up on the building downtown Portland. That's a super cool feature that was added. So what type of maintenance typically, and then does the wildfire smoke affect these any differently?
Um, I'll take a stab at that. I think, typical in kind of commercial building, it's usually we're kind of chasing, kind of the swing season is when most of the filter maintenance has to happen. But the filter swaps or filter cleans 2 times a year is pretty typical, kind of in your fall, in your pollen months in the spring, and then in the fall when the leaves and wind start blowing around. Um, and in terms of, so I think the filter side, there's two filters on these most most DOAS systems or ERV systems. And then there's kind of your typical, control checks, maybe every year, just to make sure everything's kind of operating. A lot of these systems have alarm features, which is nice if there's anything goes down. Some of the more, package systems will have that capability. And then, but mostly outside of that, we don't see a whole lot of maintenance like on the fans or any of that. They're sort of, most of them are pretty high efficiency, closed seal bearings. But it's mostly just kind of the filter side. And if it's just a simple DOAS system and it doesn't have trim coils or anything else, then yeah, I'd say it's mostly just the filter side and kind of control checks.
I was just going to say, I don't think there's any added maintenance above what you would you should be normally doing with your HVAC system anyway, right?
Right.
I mean, I think that tends to be the big issue is if everybody was doing the maintenance as they should, it would probably change a lot of things, but I don't think there's anything advanced on the maintenance for this type of system beyond what normally is there. And filters tend to be the big thing.
That's a good answer for that. And then Nicholas follows up. Have you seen instances of biological growth inside issues inside the cores in the humid locations?
I have not.
I haven't either. I haven't heard anything like that. So I don't know.
Short answer.
Yeah, I haven't seen anything. I think I saw Jordan from Energy 350 was on. He does a lot of our work with the case studies and stuff. I don't know if he's seen anything like that. He would have a better answer, but I have not heard anything of that from any of our people.
Yeah.
And then I had a question and maybe you all don't know, but from a sales perspective, is there an average payback on this, or are the systems? It looks like they've been just parts of such large projects that maybe you don't know. The savings are incredible, but are the costs of the systems? Do people find payback on those?
Absolutely. I mean, it's kind of a hard comparison to make because the code now is all DOAS. And if you're going to sort of put a new system in and you don't, and you've got an existing system that isn't DOAS, there are some allowances to kind of replace those, but that's generally how the codes are oriented. But when DOAS was first sort of getting implemented in, I think it was 2015 code is when it first went live. We were doing a lot of the cost effectiveness stuff there against, like rooftops, packaged rooftop equipment. And it was like 3-year payback just because the savings were so big on the ventilation load. And that's the reason that it was, put into code in the 15 code for, 3 or 4 building types. So a very cost effective measure. And usually when something is in the code, it's cost effective. And so that's sort of your, case there.
Great. That we have no more questions. So I think we can go ahead and end. Do either of you have any last thoughts or any little nugget of takeaways you want people to have?
No, I'm just thanks for letting us come and talk about it, and if they have any questions, please, send us an email or visit Better Bricks because we've got a lot. And NEEA's put almost everything that we've done with this on Better Bricks, so there's a lot of information there that people can get some really good answers. And if they don't see their answer, yeah, let us know because we'll definitely talk about it.
Yeah, Better Bricks is a really great resource. Loved the case studies. And as a reminder, the slides and the recording will be up on our website in about a week. So you'll have those to refer back to if you want. Visit Better Bricks, get in touch with Shawn. He knows everything. So with that, let's end this day and we'll see you in a couple of weeks. Thanks, everyone.
Great.
Thanks.
Thank you.